we've been asked to find the area enclosed between the y-axis and the right-hand side of this cardioid. It just came to us in this picture, so it wasn't that hard to describe. Well, area in polar coordinates is found by integrating between two angles 1/2 r squared d theta. And so for us, that's 1/2, and then r is 2 minus 2 cosine theta d theta. We just need to find two angles to deal with. Well, my cardioid would be traced out between 0 and 2 pi. So if I wanted the full area of the cardioid, I'd just integrate from 0 to 2 pi. But here, I actually think I could think about both of these parts that are shaded as being between minus pi halves and positive pi halves. But what I'm going to do instead is integrate from 0 to pi halves, which would just give me that top one, and multiply that integral by 2. Use the symmetry. Well, that's nice. I forgot to write the square there, so that's going to be really important, 1/2 r squared. But the 1/2's cancel. And now in this next step, I'm just integrating from 0 to pi halves, and I can multiply this out. All right, so now I'm left to deal with this integral. Holdover from a previous problem, please excuse me. All right. So I have the integral from 0 to pi halves of 4 minus 8 cosine theta plus 4 cosine squared. Well, that's 1 plus cosine of 2 theta over 2 using that formula for lowering powers. All right, just continue to work on this a little bit. The integral from 0 to pi halves, still have my 4, my 8 cosine theta. 4 divided by 2 there is going to give me a 2. And let's just go on and distribute that 2 plus 2 cosine of 2 theta. All right, combine my like terms and we'll finally be ready to find an antiderivative. Pi over 2. Now let's see, 4 and 2 makes 6. All right, I think we're ready to find an antiderivative. 6 theta minus 8 sine theta plus sine of 2 theta, because when I think about the substitution, I'd have to divide by 2. All right, and we're evaluating that from 0 to pi over 2. All right, well, this isn't too tricky. I definitely get a 3 pi hanging out here when I plug in that pi over 2. Plug in a pi halves here, and I'll get a minus 8. And then the sine of pi is 0. Plug in a 0, and they all become 0. And so I just get that 3 pi minus 8. And that's the green area I was trying to find. The area shaded here, 3 pi minus 8. And just in case someone was curious to know what that was approximately, we have 3 times pi. If I can hit the right buttons on the calculator, 3 pi minus 8 is about 1.4. All right, so there is that polar area.